Welcome. We were seeing an example of classification. Actually, we are learning the deployment of machine learning model and we are creating a loan eligibility prediction chatbot. So in that, so far we have done up to this heat map. Now we want to do from this pair plot. So this lecture is in direct continuation with previous lecture. So you cannot view this directly. You have to first view previous lecture. Now pair plot is just scatter plot between any two variables. So these are the column names of train df and test df. So you take any two variables, say gender and loan status. So how gender is related with loan status, then married or marital status and loan status, education and loan status. And that is not necessary that every time it should be loan status. You can have a pair plot between gender and married also, or you can have a pair plot between gender and self-employed also. So take any two variables out of all possible variables and plot a scatter plot, and we can do that in one single step like this. This is Seaborn library SNS dot pair plot, and as an argument I will give just whole data frame. So you can get all pair plot in one, but this is applicant income versus co-applicant income. So how applicant income and co-applicant income are related, roughly this kind of distribution is there this time, while this is applicant income versus loan amount. Now there is quite linear relation, and normally you can say that those applicants who have higher income, they ask for higher loan. This similar is the pair plot for test data set, which we can plot like this. Again, SNS dot pair plot STDF. And as such, we do not expect much change because the distribution remains same. Actually, from same data set, only train and test split is done. But this time, they have directly given us splitted data set. So now we drop this loan ID column because that loan ID column is nowhere related with the final outcome, whether or not the loan will be granted. It is just a unique identifier for each record. So we can drop it from both train and test data set. Now we plot the histogram, okay, for each column. So then this is histogram of gender. As you see, there are two categories, male and female, and it also shows the distribution of the various data points. Then on y-axis in histogram, there is always count. Then histogram for married. Again, there are only two categories, whether married or not married. Okay, so that means that divorced and other category are not present in the data set. Then histogram of dependents. So as I said, four categories, 0, 1, 2, or 3 or more, all are clubbed in one. Histogram of education, there are only two, graduate or not graduate. So all graduate and higher than graduate, all they must have been clubbed here. Okay. Then self-employed, yes or no. There are two categories. This is histogram of applicant income. And applicant income varies substantially. So that is how it is a somewhat normal like distribution, but it is extending on this side up to this. So there can you can say that these are outliers, but you will not remove that because in income can vary from anything to anything. And in fact, higher income people are the people who are more targeted by banks for giving loans. Then this is co-applicant income. Again, it is also varying over wide range. Then loan amount, this variable loan amount in $1,000, that is quite normally distributed. Again, of course, it is extending on this side a lot. So, and there can be some outliers, but some people who have high applicant income will obviously ask for higher loan amount because we saw that correlation between them was higher, 0.57. Then loan amount term. So this is actually a ordinal kind of variable that is term in months. How and 120 months means 10 years and so on. Credit history, there are only two. Zero means bad credit history, or that is no credit history or bad credit history, and one actually means good credit history. Okay. Histogram of property area, there are only three possible options. Property can be located in urban area or rural area or semi-urban area. Histogram of loan status, again two categories only because binary classification, yes or no. And you can see that around 400 are granted the loan and 200 are not granted the loan, and that means there is a such quite lenient criteria. So that is expected in US because many of the people, most of the people there have their credit history, and you will see later on that credit history decides. Now, box plot for outlier detection. Just detection because whether or not we want to remove them, that is, as I said, subjective thing. And here I think it is better not to remove them. But in applicant income, there are quite large number of outliers, which we saw even from histogram, co-applicant income also, loan amount also, and loan amount term that, well, this box plot does not, is not very good box plot. Similarly, the lower one. Now, these two I have left for student exercise, that so far we have done exploratory data analysis, and all those things which we have done by code, that can be done by one single step, pandas profiling profile report. We have already imported pandas profiling in this. Here I have commented it, so you have to uncomment that and just run these two codes. Then you will see that all the effort can be done in just one line of code. Okay. Now this is data transformation and feature engineering. So we display our train DF new. New means just that loan ID column is removed and test DF new. But this time we want to see which are continuous variable, which are categorical variables, like that. So you can see that here somewhere in this, you can see there are categories, male or female, and histogram also said them. Married also had two categories. Dependents had four categories, 0, 1, 2, or 3 or more. Then this also is categorical. This also is categorical, and these are all numeric variable: applicant income, co-applicant income, loan amount term. Credit history, though it is given as a number 1 and 0, but it is better treated as a categorical variable because either one has bad credit history or good credit history. Only two possibilities are there. So property area is also categorical, and loan status is also obviously, just only two options are there. We saw earlier that there are some non-values. So for this continuous variables or these numeric variable, maybe they are floating point variable, but for them we will replace none by mean, and for rest of the categorical variable we will replace none by mode. Now this is very simple imputation strategy, and imputation itself is such a topic that people have written entire book on what is the correct strategy for imputation based on the data. So there are more complicated and more advanced algorithms for imputation. For example, one well known is KNN imputation and others. So here we will use simple. So for continuous variable, we will use by imputation by mean. Okay. So for that, this is for train DF loan amount and test DF loan amount, and replace wherever there is none by fill NA, means fill wherever there are non-values by mean of the columns. Okay. So we fill for that. Okay. Then other also are numeric variables as such, but we earlier saw that they do not have the missing values. Only one, this loan amount had some missing values: applicant income, co-applicant income, and loan amount term. They did not have any missing value, so there is no question of filling them. Rest of the parameters are categorical, so they should be replaced by mode, that is the value which is occurring the most number of times in that column. Okay. So in train DF also and in test DF also we are imputing. So we impute, and then if you remember in the previous lecture we had designed one function. Yes, this was that function. And we called that function. So we got zero values, none values, etc. This is before we applied the treatment. But now after we apply the treatment, let us see what happens. This was in train DF and test DF, but now let us see what happens in train DF new and test DF new, where we have already done the imputation. Okay, so checking that imputation is done or not. So if you check, there are 12 columns and there are 0 columns which have missing values, and here also 0 columns have missing values, and there is nothing. So the output clearly shows that imputation is successful. Then summary statistic for train DF new and test DF new. Now this time I have not taken that option, include is equal to all. So it will include only the numeric features. And similarly, test DF new, it will include only the numeric features. If you want to do, you can do normalization, but we will decide on that after seeing the accuracy, because here our main purpose is not to get very high accuracy but reasonable accuracy, and we want to learn deployment of this model. Count of unique values in all columns. Okay, so gender had 2 unique values, married has 2 unique values, dependents 4 unique values. This we also saw from the histogram. And why this count is required, that you will see that ultimately when we want to make a classification model, these variables which are already numerical, they are fine, they can be used as they are, but rest of the variables which are categorical variables, these all gender, married and all that, they have to be converted into numerical variable, for which there are techniques which are called encoding techniques. Now, which encoding technique to use, that depends upon how many categories are there. If there are fewer categories, say 2, 4, these are less categories. Similarly, here also 2, 3, 2, 2, 3, even 12, some people may consider less, but I will consider that they are high categories. Then 2, 3, they are less, smaller number of categories. Then for them, we can use one simple encoding strategy which is called get dummies, that is dummy encoding. Because why they are dummy encoding is used only for small those columns which have less number of categories. You will see that actually with dummy encoding, if there are 2 categories, then they will be converted into 2 columns. For example, gender male is equal to yes, that will become one column, and gender female is equal to yes, that will become another column. So 2 categories will become 2 column. And yes will be given number 1, no will be given number 0. Okay, so from one variable, one feature gender, there will be 2 features generated, gender yes, one column, and gender no, other column. Married, again married yes and married no. In short, what I want to say is that more number of features are generated based on how many categories are there. So there is there is one option here, drop first. So when you drop first, at that time only one, say only those are kept where gender male is equal to 1. So obviously for other observations, gender male is equal to 0, that is implicitly included inside our data set. So but still, if you try to do it for such a large number of categories, then you can understand that for 2 we get for one, from one feature we get 2 columns here, because there are 2 categories. Here we, from one feature dependents, we will get 4 columns because there are 4 categories. Then for this, so many columns will be there that the data set will become extremely wide data set, and it will become very unwieldy and not easily malleable to further analysis. So for this type of features, where there are large number of categories, we will use another type of encoding. Here we use dummy encoding, but there we will use label encoding. That is the reason why this step is important, that you have to decide how many unique values are there. Let us encode categorical columns. First, we make a list of categorical column and then we do dummy encoding in test data set and train data set. So we do it this way and then we do check it. That now you can see this is what I was saying, that married yes, that has become one column. Married no is not there because we have dropped first. So that is why from one only one column is created. Actually two are created because you get the observations where married yes is there. That means implicitly it is clear that in the remaining observation, I mean married no is equal to 1 here and so on. Similarly, this gender also, only gender male is there, gender female will not be there. So there up to from two columns are generated, but we have dropped one column. So this keeps the number of features in control. Then in that dependence we have not taken, so there also we will take it in the label encoding also. So even four categories, we are considering them as a large number of categories. Okay, then dependence, loan status, etc. Then for them we use another technique which is called label encoding, and here we create first import label encoder from sklearn dot pre-processing, then create a label encoder object, and then we use this object le dot fit transform, and first for train df new and then for test df new, first for dependence and another for loan status. In test df, loan status is not there because that is what we want to predict for the test set, and then on based on how accurate those predictions are, we will decide how accurate our model is. And here we have displayed it. Label encoding is a great technique in the sense that number of features does not increase. Only the feature which is having multiple categories, say 12 categories, then they will be given numbers 0, 1, 2 up to 11. Say dependents had 0, 1, 2 and 3 plus. So now they are converted into 0, 1, 2, 3. Number of column has remained one only, dependents. Okay. So this is called label encoding. Now checking if that encoding is successful or not. Checking the data types of all columns, and you can see that all are integers or floating point or uint, which is even smaller integer. Okay, so in short, all are now numerical variables. So this is important because before doing any modeling activity, all the variables must be converted into numerical variables, then only a modeling can be done, because the modeling is basically a mathematical process, so you cannot do it on verbal data.